Welcome again, ladies and gents, to another flipped lesson. Today what we're going to learn is how to use various methods to measure pH of a substance, and our main focus is going to be understanding how indicators work. So we learned pH means the value that determines how acidic or basic a solution is. It's calculated by looking at how much H plus is present in a solution. The more H plus we have means the more acidic we are. The less H plus we have means the more basic we are. So there's three different things that we can use to go ahead and determine the pH of a solution. The first thing we can use is something called pH paper, which is what you see in this upper corner right here. What pH paper is it's a piece of paper that you can go ahead and dip into any solution. And when you dip it into the solution, it's going to change a color. And that color is going to dictate what pH value you have. So for example, we can see here that this has turned a blue color, and you can see that there's some blue colors up here. So this would be somewhere in the pH range of 9 to 10 for whatever solution it was dipped in. So each pH paper is going to have a color key that it comes with. The reds are going to be more the acidic values like 1 and 2. The purples are going to be the more basic values around 13 and 14, and it kind of goes in the color of the rainbow. So we can use the color that the pH paper turns to determine what our pH value is for that unknown solution. A more accurate method is to use something that you see down here in this bottom right corner, which is called a pH meter. What a pH meter does is it measures the voltage difference. So it's basically kind of looking at how many ions are in the solution to determine the actual pH number for your solution. So here we can see that whatever this probe was dipped into, it was giving a pH rating of 8.2, which is on the basic side of the pH. These are extremely accurate because they just go ahead and give you the exact pH of your solution. There's no matching to a color. There's no, well, this is kind of a 9 and kind of a 10, so maybe it's a 9.5. You get the exact number of that solution for its pH. A third way that we can measure pH is through something called using an indicator. An indicator is going to be a solution that's going to have a color. It's going to be made of a weak acid or a base, and what's going to happen is that weak acid or base is going to separate within a certain pH range, and when it does that, it's going to change colors. So for example, this indicator that we're using over here is called phenol red. It starts at yellow and it turns to red. So as you add acid and base to it, you can kind of get an idea of what color it might be. So over here we can see it starts as yellow, and then we can see it kind of turns a little bit of an orange color, and then it's more red on the other side. Now the thing about these indicators is they're not going to be as specific as a pH paper or as a pH meter. They're only going to give us a general idea of what a pH can be, not a very specific numerical pH. So if we look at this example here, the yellow side with the H in front is going to be your acid side. Over here, where you don't have the H in front, IN means indicator, this is going to be your more basic side. So when we add an acid, what we're doing is we're adding it to the side that has the H in front. So if we were to add an acid to this specific indicator, we would see the solution turn yellow. If we added a base to this indicator, we would be on this side, we would see the solution turn more red. So how do you know for an indicator whether you're going to be on the acid side or whether you're going to be on the base side? In your textbook, you have this chart. And what this chart gives you is a bunch of different indicators down the left-hand side, and then the colors that they change, and all these little blocks are what we call the range for transition. So this shows you where the pH is going to change colors. So this side of your indicators is all called the acidic side. This side of your indicator is all called the basic side. So the tough thing about these indicators is they don't give us a specific pH value unless you fall exactly in the transition range for the indicator. So for example, with crystal violet, it goes from yellow to blue from a pH of 0 to just about a pH of 2. So that means any solution that we put in it that has a pH of 2 or higher is all going to look the same color. So unless this solution is yellow or green, we really don't know whether our pH is 2 or whether our pH is 14. because this changes color at a very, very low pH. If we look at something like the phenol red in our last example, we can see the color change goes from yellow just below a pH of 7 to red that's just above a pH of 8. So if it's yellow, we can be anything from about 6.8 or lower. If it's red, we can be anything from about 8.2 or higher. So if we're orange, we know we're kind of in the middle of that range. We know we're in the mid 7s. So a lot of times when we use indicators, we don't just use one indicator to try and determine pH. We'll use a bunch of them to try and figure out what the pH could be. So these guys here, where you see these color bricks, are going to be the range for the change of transition. So when you are filling out your Google form, you are going to be using this slide to go ahead and kind of answer a few questions. I've also posted this PowerPoint online, so if you want to go ahead and just find this slide in your PowerPoint to answer the questions on your Google form, you absolutely can do that as well. Now with indicators, the color change is going to occur within about a range of 2 pH units for most indicators. You can see on the chart that some of them have a little bit wider range, some of them had a little bit smaller range, but for most indicators it's about a pH, it's about a 2 unit pH change. So what that means is if you are putting that indicator into a solution and the pH is within the range, you see a mix of the two colors, which for the phenol red example would be orange. If it's below the range, it's going to have the acidic color. If it's above the range, it's going to have the basic color. And all that means is kind of what I showed you on this slide. So if you're in the range, you're going to have a combination of the colors. If you're below in pH, you're going to be the acidic color. If you're above in pH, you're going to be the basic color. Now there are some limitations to the use of indicators. Because we're looking for a color change, the solution could be colorless. If, for example, you were trying to determine the pH of a solution that was blue in color, and you put the indicator in and it stays blue, how can we tell if that's because the solution was blue or because the indicator turned blue? So we really should be using colorless solutions when you're using indicators. You need the ability to detect very slight color changes. Some of your indicators, the color change is from like clear to pink. So you could have just a very faint light pink and have that be what your indicator is giving you. So you have to be able to pick up those very small, slight changes in color. And like I showed you on the chart, these can only give you an approximate pH. They can't give you a specific number like the pH meter or the pH paper does. They can only give you, well, okay, you're yellow, so you could be anywhere from a pH of 0 to a pH of 6. So you can only get an approximate pH with these indicators. And they're dependent on temperature. Temperature does impact how these indicators work, which isn't a huge deal for our lab, but a lot of these indicators are used out in the field when people are testing different water samples. So if they are in a very cold area using some of these indicators, it can impact the actual reading, which can be an issue for their data. So scientists got really smart and they said, okay, some of these indicators, since they don't really give us approximate pHs, they just give us kind of you're within this range. They decided, hey, I bet you if we mix a bunch of these things together, we can get all the colors of the rainbow and cover more pH values. So they call that universal indicator. So if you wanted to use a liquid indicator that was going to give you a more specific pH reading, you would want to use this universal indicator, which is something we will be using in class. So we're going to do a whole lab on this tomorrow. Please come with questions before we get going on the lab, and go ahead and head to the Google form and answer the few questions I have for you guys. Have a great night, guys.